What? Oh, right. Yeah. Wait, no. Your explanation makes no sense, and at least I have some general explanation that we did assign.
No, it's right before break. Winter break.
Oh, yeah, no, I'm talking about after Thanksgiving.
After Thanksgiving, for sure. Okay, so you have your tests back. You've had a chance to take a look at them. Test corrections are due for anyone who got less than 90% or 90 points. When are test corrections due?
Next class.
It is next class, isn't it? It's on Monday. So as the class after a weekend. So please make sure to take a look at what you did. For any errors, fix them, put it on a post-it note and cover up the errors so that it's like it never existed. And the big thing is learn from it. Make sure that you understand what you did wrong. And then when you see that again, do it the right way. There were some issues with graphing that I want to talk about. So what I've done is I've taken some components of some of the graphs. If you could go ahead and put your tests away for now, I'd appreciate it. So I've taken the components of some of the graphs that were problematic, and I want to share them with you. And I'd like for you to discuss with your neighbor what the issue is like with the axis. And it's not that there's no graph here, because the issue is with the axes, unless there's a graph on here. Each one of these was repeated by at least a couple of people, so it's not like I'm picking on even one person, but I just want to share with everybody. So go ahead and discuss. What's the problem with each one of these?
Oh, yeah. Oh, yeah. I think that might be. Maybe that's scientific.
And also.
Number 15 when you get the name. Oh, yeah. I got two. Me too. I got it all. And you got 8 for the one. Yeah, I know. I guess because
it's high.
I feel like it's wrong. It's not proportion match.
higher or being.
Oh, that's true. That people who does better. I like that really good. Like, what do you need?
Okay. So each one has some interesting things. Like the first one, the problem is, yeah, Andrew.
The scaling.
It's-
like widely known.
Yeah, it's there's a problem with the scaling. Remember, on the test, your goal is to give me your best. Oh, I should make a slogan. Seriously, you're bringing your A game. Hopefully, isn't that the plan on a test? So I want to see some really good work, and it starts with your homework. But even before that, it begins with comprehension. So I understand what's going on here, and I know I've told you that you don't have to make tick marks, but if you need tick marks to keep your scaling appropriate, then please do use them. But if you choose 5 to be here, then just make sure your -3 is appropriately placed, like maybe over here, right? No, this is not a good place for a -3. It's closer, but maybe, I don't know. Tell me when to stop. Where should -3 be? Maybe about here? Yeah. Am I going to get out a ruler and measure that your proportions are exactly right? No, I'm not going to do that, but I want you to be mindful. If you're saying that 5 and 3 have the same magnitude, there's a little bit of a problem with that. This one, this is a 5 up here. I hope you agree that this is just a little screwy, right? This dashed line, I imagine, is the sinusoidal axis, which means it should be the middle, which creates a tremendous imbalance here, doesn't it? Now, if with appropriate labeling, it could be technically right, but I want to see a nice balanced graph when you're using yours. Here, what's happening here?
And the 1 is in between this, right?
Yeah, so this isn't wrong because 1 is directly in between 5 and -3, so that's fine. But the issue is it's not a dotted line. If it's solid horizontal, that should be the x-axis. If it's vertical, then that's the y-axis. Please don't relabel your axes unless there's like some special reason that you must do it, and it probably shouldn't happen during a test. So be careful about something like that. This scale, there's a little bit of scaling issue. I think the 1 and 5 are pretty good, don't you think? Like the scale is okay with the 1 and 5. Mm-hmm. It's not bad there. -3 is a little bit lower than I'd like, but that's not a huge problem. It'd be nice for maybe -3 to go over there. The problem was there was a sine wave in between this, which leaves me wondering, what's the point of the upper and lower dashed line, right? I just want that to go right through the middle. I don't need to see the lanes. I need to see the middle of the function. So there's those 4 and a few more. Again, these are repeated multiple times. Go ahead and take a couple minutes or a minute to discuss what's my issue with these.
That one is like not scale, whatever the negative. Or that or the last.
-1, well, you can't go with being -1. 4 AM was.
Well, I guess they could be saying, hey, that's 4 PM the day before. Yeah.
Maybe, but like, I feel like.
4 AM,
I feel like it's-
That makes sense, but what he's trying to say is that it's not a.
Right.
Okay, so this one. I think we could all understand what the person's saying. Or we know the problem, right? There's a 4 AM, there's a 4 PM information, and we know that it's periodic. The next half time happens at 4 AM. So make sure your tests are put away. So what my recommendation is, if this is 4 AM, which I think is really good thing to mark, then I think it would make sense for this to be 16. And for this one to be 28, and the 28, of course, came from just a 4 plus 24. Of course, if you want to put like 4 AM below it for your own reference to kind of help you work things out, but in a math class, when you're making a function, we need number lines, like full number lines that don't have repeating and possibly confusing values, in that they're both 4s. That's just weird. Maybe positive 4 and negative 4, but to have several positive 4s on the same axis indefinitely, it's a little strange. So keep that in mind for next time. This one, you see what's weird about this middle one? Some scale issues and maybe not scale. I don't know. Like, where's the y-axis here? It seems like this is the y-axis, but if that's the case, there's a whole bunch of issues, right? On the left side, the scale is 1.5. The right scale is half, which is inconsistent. So I'm guessing that this person meant, or these people meant, for this to be just x equals -1, which is a little strange. So again, just make sure that the vertical axis is the solid one. And if it isn't, at least label it. Here, there's a couple interesting things. What's interesting about this? Yes, Andrew.
What value is that in the middle?
That says 12 p.m.
Yeah, scaling also like crazy up.
Yeah, well,
You go from 4 PM to 12 PM.
yeah, can you go from 4 p.m. to 12 p.m.? Does that make any sense?
No, it should be 12.
It should be 12 a.m., right? It should be 12 a.m. That's the one that's in the middle of these two. So that should be 12 a.m. Be careful. So if that were 12 a.m., then there's another little issue. What's that?
Isn't it supposed to be 0?
Zero.
It's on the axis.
Yeah, it should be 0 here. And there's one other. Yes, Nola?
If that's 0, then it can be negative. It's not negative. Negative.
Yeah, we want negative numbers here, right? That's how the number line works. Negatives on the left, positives on the right. And so would -4 be appropriate here?
No, really.
It would have to be negative. What number should this be if it's negative?
Eight.
Is that right? -8? I think about it, how far before midnight is 4 p.m. It's 8 hours before. So this would be more appropriate to be -8. And for this to maybe stay with the 4. So just make sure you're keeping these things in mind. And I realize that I'm guessing that one of the problems is all your math classes up until this point have had the grids for you pre-printed. Does that seem right? They've always been pre-printed, like draw it on this grid. I think that's our tendency. And then this year they're just gone. This year is just, can you make your own? So the answer is yes, you can make your own, just continue to be mindful about it. And if you want to make tick marks, you may. But don't go crazy with the tick marks. Like if you don't need them in a particular place, don't worry about them. Yes, Quinn?
Are we allowed to use like the little mini plot?
You're always welcome to bring a mini plot, yes. Good question. Sometimes those are limiting in terms of if you're trying to get a certain scale, you just have to make sure to scale it appropriately. So yes, but be careful. Okay, so let's do that's kind of like the pre-warm-up. That's a warm-up to the warm-up. Right, which means there's more. Let's see what I can do here. New share. Throwback. Can you please graph this? Make your own grid. Graph it. Where are we? Let's see how much you've retained.
That doesn't. Oh, no, no.
A little bit stuck, checking with your neighbor. Get some tips. Good exercise. Good asymptotes. Thank you. Minor tips. Open and deep. I would like to put up a. Thank you. Does it match yours? Does it look about right?
Oh.
I remember the third horizontal asymptote, like which one because.
It's like the same thing.
Even and the ratio of the coefficients. It's the same degree top and bottom. Which was the horizontal asymptote. Okay, cool. I hope you enjoyed that. Let's do the actual stuff for today. Now that you're all warmed up. Let's move a little bit. Okay, here we go. Don't have any room for this, but I'd like to talk about inverses in a mathematical sense. For example, the inverse of addition is subtraction. The inverse of multiplication, division, the inverse of square roots, specifically squares. The inverse of cube roots would be cubing. And when I'm talking about inverses, what I mean is like, if you see something like this, x minus 3 equals -1, I don't want you to think what works. I just want you to use the inverse operations to undo whatever's with that with the x. So that's where we're adding 3 to both sides. X equals 2. Yay. Welcome to pre-algebra. So inverses. As I think you may remember, functions having inverses. Do you remember anything about this? Does this sound familiar? Functions having inverses. Well, they do, and that's what we're talking about today. So I'm going to represent functions as, and I'm going to cross this out because everything I do under here is not going to be related to that. But let's say I have a function defined in this mapping relationship. We have 1, 2, 3, and A, B, C. Is this a function? Yeah. It is? Right there, there's no relationship between the two. In order to be a function or some sort of relationship, I need to add some arrows, right? I need to connect it somehow. The arrows have to be directional, so I'll do this, this, and this. So is it a function? Yeah, and using function notation, we could say that f of 1 is equal to C. Are we sure about that? F of 2 is equal to A, and f of 3 is equal to f of 3 is equal to B. By definition of this mapping, it's not algebraic, it's just here's a picture, inputs in one circle, outputs in the other circle. Here's something else. So if I put a 4, 5, and a star right here, is this a function? Exactly. Let's remember the definition of function. Each input has to have exactly one output. So if I ask you for a G of 4, you could tell me without hesitation that that's equal to star, which is weird, but it's okay. Is it just something I made up right now? G of 5 is equal to star, happens to be the same thing. And if I do something like this, I'm just gonna get boring. 7 and happy face. Okay, so is this a function?
No.
This input has 2 outputs. If I ask you what h of 6 is, there's 2 answers. That's just inappropriate. That's why we can't even use function notation for something like this. It just fails the definition of function. Yeah, if we graphed it, imagine where that happy face would be on the number line. Be pretty high up. Yes, Andrew.
X on the Y, X, 3 to 1 square is not.
Correct. It's not a function of x. Yeah, and we'll talk about those another time. Perhaps. So just like operations have inverses, functions have inverses. Would you please check quietly with your neighbor to see if they remember the notation for inverse functions? Okay, volunteer. What's the notation when you're representing an inverse function? Yes, Rihanna. Does that sound right? F to negative 1 of x. Nice. So when you see this, this is normally what we read as f inverse of x. So even though it's written f to the negative first, when you speak it and when you see it in your brain and in your mouth, I want you to say f inverse of x. And when you say it to the negative first power, that just means you're taking a reciprocal number. You say x to the negative first is 1 over x. So f inverse is completely different. It's not equal to 1 over f. So I want to separate those ideas. It's just confusing notation. So going back to my function here, if I'm talking about f inverse of a, do we see what that would be equal to? It's 2. It reverses the order of a function. So domain becomes a range. Range becomes a domain. So f inverse of a, we could say is equal to 2. F inverse, oops, why am I putting negative 2 there? F inverse of b is equal to 3. F inverse of 1 is equal to F inverse of 1 makes no sense because 1 is not in the domain of our inverse function, right? If I were asking for G inverse of star, yeah, the inverse is not a function, right? Does it make sense that that fails? Okay, and we could go on to H, but H wasn't even a function, so I'm not going to. When we're talking about inverse functions, we have to start with a function. So in order for a function to have an inverse, it has to have a particular quality. Do you know what that quality is? 1 to 1. A function must be 1 to 1 to have an inverse. Can you please discuss that with your neighbor if you remember anything and see if you can make sense of it? So I know that some of you haven't studied this, so I know you might be in a place come from confusion, but what does it mean for something to be 1 to 1? Yes, Jazzy? Okay, okay. What's that? Yeah, that's what we're looking for. Yeah, so, yeah. Nice. Yeah, so a function, every input has one output for the function, for 1 to 1 function, every input has a unique output. So I think that's what it's mentioning over here. Every y coordinate has a unique x coordinate and vice versa. So there are 4 different relations here. It's up to you to decide, are they 1 to 1? A function is not 1 to 1 or not a function at all? Think about it. It's up to you. You guys ready? The cross plan is either 1 to 1, function that is not 1 to 1, or not a function at all. Anju. Just the first one. Do we agree? 1 to 1? What kind of a display is this for a function? Do you know what this is called? We have one group, another group with arrows in it. Do you remember what it's called? The diagram. Specifically, it is called a mapping. But yeah, thank you, Andrew. Next one. Brandon, what do you think? Why not? Are we good with that? Yeah, so these 6s, I think, are a problem, aren't they? That's definitely not 1 to 1. So function, but not 1 to 1. Thank you. Next one. Who'd like to talk about this one? Hey, Rohan.
We said it's a function and not 1 to 1. So if you look at every five, they have a unique y. So if you plug in every y line, then you not have any.
So, okay, so if you plug in the y, it doesn't have a unique characteristics. So you're like plugging in this 2, you're gonna see that there are 2 different values for which that comes. What do you think? Does that make sense? That's good. Yes, it did. The horizontal line test. Does it sound familiar? Nice. Yeah, the vertical line test checks to see if the graph is a function. Horizontal line test checks to see if that function is 1 to 1. Very nice. Yeah, it checks if it has. So here you say it fails. The horizontal line test. How should I spell horizontal line test? HLT. So vertical line test checks to see if it's a function, specifically a function of x. And Miles, this is why I was hesitating to answer your question. Horizontal line test could check to see if it's a function of y, but we don't normally do that. But once you have it, the fact that it's a function of x, horizontal line test just check to see if it's one-to-one. That's it. And this one, this crazy one, Andrew. Why not? Yeah, not a function. Here. Function. Not. Yeah. And we need our function to be one-to-one if it's going to have an inverse. And that all just comes from this diagram right here. It needs to be one-to-one in order to have an inverse. So how do you get the inverse? Oh, I'm sorry, I forgot to do this one. If a continuous function is decreasing over an interval, can you determine if the function is one-to-one? Well, let's say that our interval is from A to B. And let's say that's the only place our function exists, just in that window. So it's here inside these dashed lines. These are not necessarily a vertical asymptote, but there's nothing happening outside of that. If the function is decreasing there, is that enough to say that this function is one-to-one? Please discuss.
Actually, no. Wait, does that mean that it's always increasing?
On the interval, yes. So nothing's happening outside the interval. We're just considering our world as from A to B. And only decreasing, yeah, correct. So what do you think? Yes or no? Is that enough? Yes? No? Yes? No? Yeah, why not? Yeah, Chazzy. So it could be a parabola like here. Like this. It could be something like this. Yeah, I'm trying to keep it just in the interval. Just in the interval, right? So there might be something else going on outside, but I'm just saying in our world that happens from A to B, is this function going to be one-to-one there? Is that enough? Yeah. It is. Right, if it's not strictly decreasing, then that means it's going to have something like this, and you can see that suddenly it fails the horizontal line test, doesn't it? If there's any sort of increase. So just knowing that it's decreasing is enough to say it's one-to-one on a specific interval. How about increasing? Same thing. And that interval could be negative infinity to positive infinity, but considering any interval, if it's only increasing, only decreasing on that interval, it is one-to-one. Yes.
But I feel like we should make the wording more specific, because if they say if it's continually decreasing, then like you just said, yeah, decreasing could be like overall.
Yeah.
Maybe it could be like something in the middle.
That's kind of like, that's how you have to think on tests, isn't it? Like, is it always that, or is there an exception? Is it this other rule that I'm not thinking about? I'm not thinking about too easily, and that's one thing that could grow up kind of trained in with geometry. A counter example, the example outside of the words that are given. So I agreed we had to tighten up the words on this. That's why I tried to like limit, change it to interval, but I hope we get the idea. But if it's decreasing on an interval, it's one-to-one at least on that interval for sure. Okay. So making inverse functions. Who remembers how to make an inverse function? A few people. Let's see if you remember. I'm gonna put this over here. Let's say that f of x is equal to 3x plus 1. Is that a one-to-one function? It is one-to-one. Go ahead and make the inverse if you know how to do it. If you don't, just hold up. I'll tell you how to do it. I just want you to find the inverse function. Was anyone able to successfully do this? Oh, no. Let's just check. Step one. Replace f of x with y, if necessary. I agree with what you're saying, by the way. All right, so it's nice to have a y in there. And this is kind of optional too, and I'll explain what that means in a minute. Next step is the one that I think I heard. Take the x and y and switch them. Switch the x and y values. Next step. Solve for y. I'm going to say solve for new y just to be completely clear. For new y. And then as a step 4, I'm going to ask you to replace y with how do we say this? F inverse of x. Just to make sure it's very, very clear that is the inverse. Okay, so doing that here, that's what we did first is y equals 3x plus 1. Then you said x equals 3y plus 1. And then from there, maybe you do 3y equals x minus 1. And y equals x minus 1 over 3. And finally, f inverse of x is equal to x minus 1 over 3. Somebody's asked if you should solve it. I wasn't sure what that meant, but yeah, you do have to solve for the y. F equals something or other. So what is f of 2 equal to? Do you know? F of 2 is equal to 7. How about f inverse of 7? What is that equal to? Is that equal to 2? Are you sure? Does that make sense that has to be equal to 2 if these are inverses? Remember, it just takes the x and y and switches them. So if you're plugging x into the function, you get y. So you plug that y into the inverse function, the original x. You can actually spit out what you started with. That's the essence of the inverse function. Yeah? Okay. Let's move on. I'm going to change both of these. And erase a 2 there. And I'm going to be changing this in just a moment. So would you please find the inverse function? Oh, we're going to be doing some graphing here. So I want you to split this in half and work small in the upper half of the portion you have to work with. Find the inverse. Second with the neighbor when you're done, and once you do, I want you to discuss the domain and range of the function and its inverse. We'll call on someone to help me with just a minute. It's already time. Sabrina, can you help with building the inverse function here? Okay. Oh, interesting. You squared both sides. Okay. Let's do +4 first, so it equals y minus 3. And move the 3 over, so y is equal to, squeezing it in here, so this is, oh, +7, excuse me. And finally, did anyone else get that? Thumbs up everywhere. Thank you, Sabrina. Any questions? Okay, let's talk about the domain of the original function. Did you already get there? Domain of the original function. I'd like to hear from Rihanna. What's the domain of the original function? Do you know? Exactly, so that the contents of the radical, which are called the radicand, this x minus 3 has to be, it can't be negative. In other words, it has to be greater than or equal to 0. Isn't that the same thing as can't be negative? So from this, we see that x has to be greater than or equal to 3. Did anyone else already have that? Did anyone not use algebra to do that? Just figured it out by looking at it? Yeah, that's called intuition, and that's great. Don't lose it. Please don't lose your intuition and your natural sense of just math. But when that fails, you please remember to outbreak that to help.
The main of the function is, what else do we know about this?
The range of the inverse is. Well, the inverse, the range has to do with y values, but we do now know that y is greater than or equal to 3. Does that make sense? Without doing extra work, because remember the sets have changed, it's flipped. Can someone talk to us about the range of the function, that's what that's, the range of the function. Go on for 400.
And then what we do is we can find the different number of estimates that can write that way. And
So you find the range of the inverse function. Does that make sense to you, Max?
yeah.
Yeah, it is. It feels like it's all the numbers, but we have to be careful about it. It's not actually really good idea. Let's talk about the range of width, or the range of width. Anyway, to think about it, discuss again, how is the range recognize it without looking at the inverse function? Higher. Oh, it's 10 seconds. Okay. So, we'd like to talk about the range of that great function.
What I do is I put in the mode to X to B, this is like C, and then that is 0. Yeah, so then the mode is the highest Y would be 2.
Did anyone else think that?
Yeah.
I like that. The highest would be.
So then Y is, yeah.
What do you think?
Yeah.
We're starting with 2 and in fact in some components. At least it's 0, anything else. I really like that. What kind of approach is that to find it? Intuition, isn't it? That's totally intuition, and really good math guy. Is there anything wrong with that? It's fantastic. I really like it. The only problem with intuition is what happens if you don't have any. Or if it fails you, because that's gonna happen. So what's another way we could get the range out of this? Or did anyone else have a comment about that X is less than, that's sort of why it's less than equal to 2? So another way to do this, not for you to do it algebraically, but to take the function and look at it. Graph. Are you able to graph this function? Yeah. The parent function is where that's where that's yeah. I have a hard time reading. Does that make sense? I'm really reading it right in front of you. What do you think that's what's gonna happen to the graph?
Yeah. And then.
You may want to think about this as negative x minus 3 plus 2. Maybe. Okay, so I think you're square of x, and then 13 you do is look at it. Well, the negative is on the outside, so the x, yeah, change the y value. It's x actually. And then from there, to the 3 to the right. So it's graphic. That's a quick sketch. I'm gonna use a full scale here. I'm gonna do 1, 2, 3, 1, 2, 3, and what do we say? 3 to left and 2 up, and then look something like this. Does that match what you were thinking? Okay. Now let's go ahead and graph the inverse function. Keep in mind we have to make an equation. I'll give you like 10 seconds before I just go over this from the start, how to do that. You know that the graphic one is a parabola, but this form is terrible. All I know from this form is that. And from this form, all we can see is that one upwards and then fully why it doesn't make it positive division. It's not helpful with that. Let's put it into vertex form. So continuous square from this we would need 4, right? Are we doing that for the most? Yeah. So I'm just gonna break up the 7 into 4 plus 3. 3 plus 4. And make a, so this is like, once you just know how to do it, hope that makes sense that is vertex form, yeah? So graphing this, we see the vertex is 2, 3. Is that a surprise that it's 2, 3? Why not? Yeah, it's the inverse of the one we had. We had 2, 2, 2, function. I'm not going to do the whole parabola, am I? Because one thing we still have to mention is that the domain of the inverse is, well, actually, would you check with your neighbor? What is the domain of the inverse? Okay, Quinn, what's the domain of the inverse? Negative infinity to 2. Yeah. Nice. So interval notation exactly, and that's the nice thing about interval notation. You don't have to worry about x's or y's. For x's, it would be x is less than or equal to 2. You are correct with what you said there. So when we graph our parabola, it's not going to be the whole thing. It's just going to be the part for which x is less than or equal to 2. So you see what that's going to do? So all we know right now is that the y-intercept is 7, which tells us that the. Does that make sense? X-intercept for the other one is 7, because the coordinates have switched. 0, 7 becomes 7, 0. Would you please discuss the relationship between these two graphs with your partner? Oh yeah. Oh yeah. Good stuff. Now keep in mind that I know that not everyone studied this. I just like to know what do you know about these two graphs? Sophia, do you know anything about these two graphs? The relationship between the two? Not going to mind. We are not excited. Does it sound familiar? Symmetric with respect to the line y equals x, or which is the same thing as x equals y. Yeah. There we go. They're symmetric with respect to this line. That's one property of a function and its inverse. I've heard that before. Yeah. Symmetry there. Cool. I think I got to everything here. Yeah, which means you have a little time to work on your assignment. Dun, dun, dun. I know your homework. Yeah, you have fun working on your homework. Okay. What do you want to do? Should I put it back? Yeah, put this back. Oh, we didn't do this last one. I'm so sorry. We need to do that last one. You can work on homework if you like after you do this. So sorry. Did this function have an inverse? How do you know it has an inverse? Is it one-to-one? How do you know? Regraph it.
Oh, yeah.
It's definitely one-to-one. But it does have, and you're still kind of secret.
And then, wait, but what about like the asymptotes?
Yeah. But we're graphing the function.
The asymptotes. With the y, so then you can work on that. Yeah.
We'll go over that in about 6 minutes before the time. Go ahead. Yeah. Well, like, wait, no,
It does.
okay. So we do the bracket.
Yeah.
Yeah, I know, that's not.
I just didn't why times one would do it.
Don't that's fine. Unless you want.
Yeah. Oh, that's what you want. I did y by with I want.
It's like, yeah.
That's fine. Y times one.
Yeah.
Divide by one.
You did. Minus x. Minus y.
I was wondering, like, how they do it on my life, right? One chapter. Because I thought it was correct, it's just like, so. Like, I just where I do wrong.
What did you tell them?
So, so then like that's the answer right there, and then we'll put that into it there. I think that's correct.
It should be close, like if it's 4 o'clock at 17 degrees. 3 o'clock is pretty close to that. The 51 is closer to what's going on down here.
Right, it was just like,
There's probably competition there. And it's plus 64, of course.
did I get this one wrong? Instead way or?
That's fine.
Where did it go?
Yeah, I think the 50 means what? So mine is just for. It's not great either.
I did it, like I plugged everything in correctly, but I just plugged it back into the calculator. I don't know what it was.
What is your calculator?
X, Y,
I was just wondering about 2 questions, then just test productions. But this one you said to see for point back. Did I get one of these wrong?
I'm just wondering how you guys.
Why don't you just do the triangle?
Yeah, where's the triangle?
I guess I should have included it, right?
Yeah, and the quadrant.
Oh,
So,
it'd be quadrant.
yeah, so like I'm looking for negative here and I'm not seeing anything, so I just not sure how that, will positive and negative.
Just from the cotangent and then the theta, because you know that. All students can calculate, so
Okay.
the cotangent means only one is negative, and you know that it's in X, right?
And how about the right over the positive?
Because the Y is positive.
But, okay, so I'd want to see if you can find it to work. In your brain. So that's what you're thinking, and I would want to see.
Negative.
the angle here, and negative 5 here and 13. Just let everything find out. I'll give you that.
Okay, and then for question one,
Yeah, think about a parabola, just because it goes out, it's so nice. It's so because, oh, okay. Okay, I'll do it back. I didn't leave that.
okay, thank you. And then for corrections, you just want post-it notes, right?
Okay. So, This is all being recorded. Recorded, huh? Okay, no, sorry to interrupt. So what do we do? Okay. Okay. To get. X as y minus. Oh, x times y minus 3, okay. Okay. Like this, xy minus 3x. Okay. Oh, nice. So this equals. This, okay. Y equals what? You mean negative 3x minus 5?
It's also over negative.
Well, let's just take it as it is. Let's not do it intuitions right now. You're doing great algebra. Let's just divide by 1 minus x. Is that okay? Okay, but you were saying that there's a different form? Nice. So ultimately landing x minus 1, and on the top would be 5 plus 3x, yeah. Yeah, either one of these is perfectly fine. Very, very nicely done. Nice algebra. Let's of course finish this up by replacing that y with f inverse of x. And I like the positive one. I'm gonna put in standard form too. 3x plus 5, even though it doesn't really matter for rational functions like that. Are we good with that? Do you do domain and range? You did? You did, okay. I'll give you a moment to discuss with your neighbor, domain and range, and I'll call in one more person to help us with the domain and range of both of them.
Yeah.
And then the other one. Presented to that.
Okay, so who'd like to tell us about the domain of the function? Yeah, Brianna? Nice. Do we agree with these things? Great. Do you know the ranges? Thank you. Nice. Why does this make sense that y can't equal 1, considering what we know? Because what? That's nice, exactly. That's domain of inverse function, but picturing the graph. Right, you looked at the graph, you see that's where the horizontal asymptote is. That y literally doesn't equal 1. It equals everything but that. And how about for the inverse function? Where's the horizontal asymptote for that one? At 3. Hence y cannot equal 3 in that case. But could a graph cross a horizontal asymptote? It could, but not when it's linear over linear. Like this, when it's simple like that, it won't cross it. So it's kind of cool how it all fits together. I hope you think so. Really, that was a lot today. Nicely done. Have a wonderful weekend.